Assalamu alaikum, respected students. Hope so you are fine. Today we will calculate the pH of 10 to raise minus 2 molar of aqueous hydrofluoric acid solution uh, at 25 Celsius. First, we make the equation of dissociation of hydrofluoric acid in water. HF, when dissociated into water, we know that HF is the acid which donates proton to the water. It means water acts as a base. It accepts the proton from the HF from the hydronium ion, and after forming hydronium ion, fluoride ion is formed, that is the conjugate base of the HF. Okay, next we make the equilibrium constant equation of this acid. React product over the reactants. We don't write down the concentration of water because water is a solvent. Solvent is constant, so we don't write the constant concentration. Ka of HF is 6.8 multiplied by 10 to raise minus 4 at 25 Celsius. To solve this problem, to calculate this pH, first we form the ICE table, initial change equilibrium. We know that initial concentration of HF is given 10 to raise minus 2 molar. Hydronium ion, we know that hydronium ion at 25 Celsius of the pure water is 10 to raise minus 7 molar, and fluoride at the initial state is 0. Okay. Next, change with respect to reactant, change is the negative x because we don't know what is the change. How much hydronium ion is formed, how much is fluoride is formed, we write down plus x and plus x. We know that with the product we use the sign positive, with the reactant the negative sign is used. Okay, next, what will be the concentration at equilibrium with respect to the reactants? Initial minus change with respect to the products, initial plus x, initial plus x. This is the equilibrium concentrations. We write down these concentration in this Ka equations. 6.8 10 to raise minus 4, and this is the concentration of IC table at equilibrium position. Now we find out the value of x. How we can find out the value of x? If we rearrange these equations, after rearranging these equations, we know that final is x squared plus 6.8 10 to raise minus 4 minus 6.8 multiplied by 10 to raise minus 6 is equal to 0. It's mean first part is a x squared that, and second part is equal to bx, and third part is the c. That is the quadratic equations. To find out the value of x, we use the quadratic equations, and we put the values of these a, b and c in quadratic equations, and we find out the final answer after solving all this equation. That is x is equal to 2.23 10 to raise minus 3, and x is equal to minus 2.93 10 to raise minus 3. We know that in the quadratic equation usually two values are calculated. Positive values is used, and we know that negative values cannot be considered and discarded. Negative root, it's not accepted. We putting these values, value of x, that's the 2.29 10 to raise minus 3 in place of x, and we find that x is equal to 2.3 10 to the raise minus 3. If we put this value of x at this point, we know that 2.3 10 to the raise minus 3 is very greater than 10 to the raise minus 7. So we ignore this value 10 to the raise minus 3 when one value is very greater than n as compared to other values, and we accept the greater value and we reject the very low values. So that is its mean value of x, that is the value of hydronium ion concentration at the equilibrium point. That is the hydronium ion. You can say hydrogen ions. We calculate the pH. We know that pH is the negative log of hydronium ion concentration of hydrogen ion concentration is 2.64. Its mean pH of hydrofluoric acid of 0.2 molar solution is 2.64. 10 to raise minus 2 molar of aqueous HCl solutions is 2.64. that is the final answer. Hope so you understand. Thank you very much.